Well, we're going to focus on properties of integrals tonight. There's going to be quite a few examples, so make sure you write each of them down. This is a pretty big idea, hopefully a nice, easy multiple choice question by the end of all of this. So, again, I just want to reinforce in your mind here that when we say integral, we are actually finding the area under the curve to the x-axis. Okay, so again, this is read the integral from a to b of f of x dx. F of x is the function that we're integrating. Okay, and we're finding that area between the vertical line A and the vertical line B. And that's the area that we are finding when we find a definite integral. So before we dive right in, we need to kind of quickly review a few integral questions here. So number 1, the integral from 2 to 5 of 6 dx. And we did all these geometrically, so it takes 30 seconds. Let's sketch it out. We're actually graphing the function y equals 6. And we're only looking at that function from 2 till 5. Okay, the vertical line 2 to the vertical line 5, lower bound, upper bound. And I just need to get that area, and this happens to be a real nice one. I see a rectangle. Area equals base times height is the first thing that pops in my head. What is my base from 2 to 5? Hopefully you're saying 3 times the height. Well, we know the height is 6, so hopefully a nice area of 18. Next one, number 2. The integral from 0 to 3 of x plus 4. So again, we're going to solve this geometrically. We're going to make a nice sketch. X plus 4 is just a line shifted up 4. Okay, so there's my up 4. We have a nice line with a slope of 1. And we're looking specifically for the area from 0 to 3. So line x equals 0 and x equals 3. And I'm looking for that area from the curve to the x-axis. Now that's one of our famous shapes there. That's that trapezoid. Area equals 1/2. I have my base, height 1 plus height 2. Want to make sure we have that memorized. I would say this has a base, if you just look at your picture, a base of 3. So we're not doing anything in our head, we're sketching it out. The height at 0 is obvious. It has a height of 4. And the height at 3, maybe it's not so obvious, but it's very simple to get. Plug 3 into your equation. 3 plus 4 is 7. So that gets me, that's 11 times 3 is 33 over 2. All right, we're ready to attack our properties here. All right, so first property, these all need to be in your notebook labeled exactly. Number 1, the integral from a to a of f of x dx equals 0. Now I hope that makes sense to you. Remember, area is going to be, the integral is going to be the area under the curve f of x. So here's a picture of f of x. And you are going from a to a. Basically, you're starting at a, and you're not moving. Your upper and lower bound are the same. You have accumulated no area. So let's make a note. We have accumulated 0 area. So it should make sense that your area is 0. Your upper bound and lower bound are on top of each other, therefore you have no area. Number 2, okay, the integral from a to c of f of x dx equals the integral from a to b of f of x dx plus the integral from b to c. Now let's make a note. We're assuming a is less than b is less than c. All right, so I like to refer to this as the splitting integral. All right, it is okay to split your integral. For example, if I wanted to integrate from 0 to 7 of f of x dx, I could split this up and say, okay, I could integrate from 0 to 4, plus I could integrate from 4 to 7. And altogether, that would total 7. I went from 0 to 4, and then I picked it back up where I left off. Those have to match. Maybe make a note there. Those have to match when you split from 4 to 7. Number 3, the integral from a to b of f of x dx is equal to the negative integral from b to a of f of x dx. All right, you can switch, and again, let's make a note in there, switch your bounds. All right, so notice I went from a to b to a. And all you do when you switch your bounds is you bring a negative out front. Now, you might be thinking, why or when do I have to do this? Well, remember, the lower bound has to be the lower number. The upper bound has to be the larger number. So if they give them to you and they're not in the right order, you have to quickly switch them. Number 4, the integral from a to b of k f of x dx, and let's make a note where k is a constant, is equal to k from a to b of f of x dx. You are allowed to pull your constant out front, integrate, and then multiply. And 5, The integral from a to b of f of x plus or minus g of x. You could be adding or subtracting. Again, I'm just splitting. I could integrate from a to b of f of x and add on the integral from a to b of g of x. All right, so those 5 properties need to be in your notebook, and they need to be, understood for tomorrow's class. So let's take a look at this graph of f. It says, consists of line segments and a semicircle as shown in the figure below. Evaluate each integral using geometric formulas. All right, so you can pause it, get yourself a nice sketch there. It should be labeled pretty accurately. And when you're ready, turn me back on and we'll attack the first one. Okay, letter A. I need to integrate from 0 to 2 of f of x dx. So 0 to 2. So I'm looking for this area from the curve to the x-axis. All right, and the first thing I say to myself, well, it's below the x-axis, so I know that I'm going to have a negative value on that. And I see a quarter of a circle, so I'm going to go 1/4 pi r squared. So that's 1/4 pi. My radius is 2. 2 squared is 4. So I'm going to say this has a negative pi value. The integral from 0 to 2 of f of x dx equals negative pi. All right, perhaps too easy. Letter B. The integral from 4 to 2 of f of x dx equals what? All right, well, first and foremost, you've got to look at those bounds. I already catch a mistake. You have to have the lower bound to the upper bound. Are they in the correct order? No, so that's one of those properties we just talked about. You have to pay attention to those bounds, and now to make them in the correct order, you just put a negative in front, 2 to 4 of f of x dx. All right, so your first move has to be to catch. The bounds have to be in the correct order. All right, so now I need to integrate from 2 to 4. So I need this area from 2 to 4. So I see a triangle, so don't forget you have a negative out front. I've got negative 1/2. Let's see, that has a base of 2. Okay, if I look here, base of 2, and the height, the perpendicular height, also has a height of 2. So I'm going to say this answer is a negative 2. Okay, now I know it's sitting above the x-axis, so you might be thinking positive area, but because the bounds were backwards, we had to switch that and put a negative out front. Letter C. The integral from 2 to 2 of f of x dx. Well, you're starting at 2 and you're ending at 2. You've accumulated 0 area. That's one of the easiest ones. That's just a big fat 0. Okay, watch that property where the bounds are the same. Letter D. The integral from 0 to 6 of 3 f of x dx. Notice 3 is that constant out front. So the first thing I'm going to do is rewrite this as 3 times the integral from 0 to 6 of f of x dx. Okay, so now I need to go get my area from 0 to 6. And I don't have to do too much math. I already know a lot about it. The area from 0 to 2, and this is where you could split. I'm just going to carry this up here. I could say I know the area from 0 to 2 plus the area from 2 to 4 plus the area from 4 to 6. All right, and like I said, I already figured out some of this. I already know the area from 0 to 2 from part A is negative pi plus the area from 2 to 4. That had an area of positive 2. And you'll notice the area from 4 to 6 is the exact same as the area from 2 to 4. So I'm going to say plus another positive 2. So I would say that answer is 4 minus pi. 4 minus pi. All right, letter E. Now, notice this is that last property that was on our list of properties. When you're adding or subtracting, you can split. So that's what I'm going to do. I'm going to integrate from 0 to 6 of f of x dx. That's a plus sign, so plus the integral from 0 to 6 of 2 dx. Okay, the integral from 0 to 6 of f of x dx is, what did we say, 4 minus pi. Okay. And plus now, I need the integral from 0 to 6 of 2. So that's what I'm going to sketch geometrically. I'm going to sketch y equals 2. I'm going to go from 0 to 6, and I need that area. That has a base of 6 and a height of 2. So I'm going to say it has an area of 12. So I would say when I tally that up together, I actually get, what is that, 16 minus pi. All right, now I do have to apologize. You're probably yelling at me back home. On part D there, I did forget after I did all that to multiply by 3. So I just want to go back and fix that. I should have 12 minus 3 pi. I apologize for that. Hopefully you caught that. It was 3 times that integral, so 12 minus 3 pi. All right, let's take a look at another picture. This time they put the areas in there for you, but you still have to be smart enough to say, because this section is below the x-axis, you need to assign a negative to it. This is above, so it's positive, positive. This guy's sitting below, so I also need to assign a negative to it. Question A. The integral from a to a of f of x dx, well, you start at a, you accumulate no area, so therefore that's a quick, easy 0. The area from a to c of 4f of x dx, I'm going to rewrite that, and I'm going to say that's 4 times the integral from a to c of f of x dx. Alright, so I have 4 times whatever that area is. So from a to c is 3 minus 1, so that's times 2. I've got a nice answer of 8. Letter C. I need the area from D to A of f of x dx. Well, do you notice anything wrong with those bounds? Is D the lower bound? Now, I know they're not numerical, but A comes before D, so I do need to switch those, so I have to slap a negative in front, and I can switch it then from A to D of f of x dx. So now if I look, I need to go from A to D, so that would be my 3 minus 1 is 2, plus 2 is 4, and because that negative's out front, I'm going to say negative 4. Lastly, I need the integral from a to e of the absolute value of f of x dx. A to e of the absolute value. So the first thing I notice is that my bounds are in order, so that's good. But absolute value is going to take anybody with negative that's below the x-axis and make it above the x-axis. So it's actually saying 3, well, let me write it out to be formal. I could integrate from a to b of f of x dx plus, I need the absolute value of the integral from b to c of f of x dx. I need to make that value positive, plus the integral from c to d of f of x dx, plus the absolute value of the integral from d to e of f of x dx. Alright, so I just want to be clear that I am taking the absolute value to make each of those positive. So I really have 3 plus 1 plus 2 plus 5. So that's 9. That's a total of 11. Alright, so now these are, that was kind of more of a short answer question. This is something that you would see on our multiple choice section. Suppose that f and g are continuous functions, and then they'll give you some givens here. Let me try to make that a little bigger for you. Okay, and you've got to pay attention to what function you're integrating and the bounds. So they're telling you 1 to 2 of f of x is negative 4, 1 to 5 of f of x is 6, and 1 to 5 of g of x is 8. So notice those two deal with f of x, this pair deals with g of x. Question A, evaluate each integral. 2 to 2. Well, hopefully you can stop right there. You don't even need to look at the function. If those bounds are the same, you have accumulated 0 area. All right, B, the integral from 5 to 1 of g of x dx. What do you catch that's wrong with that integral right off the bat? Hopefully you're saying those bounds. I have to rewrite that and say it's the integral from the negative integral from 1 to 5 of g of x dx. Okay, that's the first move that goes on every paper. Bounds are backwards, we can flip them. Now take a look at this piece. The integral from 1 to 5 of g of x dx, they tell us that answer is 8. So this is just simply negative 8. Letter C says 1 to 2 of 3f of x dx. Well, these two deal with f of x. This one has the bounds 1 to 2, and so does this one, but it doesn't have that 3 there. So that's that constant rule. You can pull that constant out front, 1 to 2 of f of x dx. Okay, and now we know the integral from 1 to 2 of f of x dx is actually equal to negative 4. So I've got 3 times negative 4, or negative 12. All right, the uglier one, D. It says the integral from 2 to 5 of f of x dx. All right, now here's where you have to get creative. These two deal with f of x. Do any of the bounds go from 2 to 5? Well, that's 1 to 2, and that's 1 to 5. So there's not a specific one that goes from 2 to 5. So again, this is where you get creative. And here's what I do. I just think about what I know. And I'll just kind of make a line for myself. I know from 1 to 2, this has an area of negative 4. All right, and I want you to do the same. I want you to draw this out. It might be elementary, maybe you can do it in your head, but draw it out. There's no excuse to miss these. 1 to 2 is negative 4, and I know from 1 to 5, oops, I have a total area of 6, so I'm going to bracket that in. Could you easily figure out the area from 2 to 5? All right, now again, if you drew this, you can't screw this up. 1 to 5 is 6, 1 to 2 is negative 4. How would you get this section here? If the whole thing is 6 and this piece is negative 4, I would say that is 6 minus negative 4. I would take my big piece and take this part away, so I would subtract negative 4, which tells me that this section has an area of 10. All right, we're going to set up another similar example here. I'll try to make it a little bigger. Suppose that f of x and g of x are continuous functions, and that, here's our givens. 1 to 9 of f of x equals negative 1, 7 to 9 of f of x equals 5, and 7 to 9 of h of x equals 4. Again, we're going to evaluate each integral. All right, so part A, we're going from 1 to 9. Why don't you pause it, see what you come up with? That's a real nice easy one, and see if we compare. Pause it, see what you get. Hopefully your work follows mine. I just pulled out that constant multiple out front, and the integral from 1 to 9 then was just negative 1 times the negative 2, and I've got 2 for an answer. Letter B. All right, notice they have that plus or minus. That's that splitting integral. I'm going to rewrite this as 7 to 9 of f of x dx plus the integral from 7 to 9 of h of x dx. Now look how simple this is. Do we know 7 to 9 of f of x? Well, that's 5, it says. And we know 7 to 9 of h of x, that's 4. So hopefully you got a total of 9. All right, letter C. I need 1 to 7 of f of x. So they give me 1 to 9 and 7 to 9. Pause it, do this one on your own. It's similar to the one we did on the last group, and see what you get. This is the one where we've got to make sure we nail this. Draw it out if you have to. So here's what my picture looks like. I knew 1 to 9, so I bracket that in as negative 1. I knew 7 to 9, which is 5, so I said if I want this section, which I'll call x, I would take the whole thing and subtract out this piece, and I'll be left with x. So I have an area of negative 6. Lastly, on D, all right, I'm going to split this up and pull out the constant multiple. So this says 2 from 7 to 9 of f of x dx, and I want to subtract 3 from 7 to 9 of h of x dx. All right, so 7 to 9 of f of x, let's see, that's 5 times my 2 is 10, minus 7 to 9 of h of x is 4 times 3 is 12. I get a nice negative 2. All right, in this next section here, we have 3 more givens and then 4 more questions that go with it here. So we're given 1 to 4, 4x squared dx equals 10, 4 to 6 of 15x dx equals 2, 1 to 5 of 6x dx equals 6. All right, so question A, I need 1 to 4 of 8x squared. Now you'll notice 8x squared doesn't match with any single one of those, but it is close to one of them. I would say the bounds are the same 1 to 4 on this function, and 4x squared is pretty darn close to 8x squared. So basically I say, how can I make this function look like this one? I'm thinking in my head, I just need to multiply that function by 2. So I'm rewriting this as 2 times 1 to 4 of 4x squared dx. Would you agree with that? I'm just taking this function I have, multiplying it by 2 to make it say 8x squared. So I would say I get 2 times 10, or 20. B, I need 4 to 6 of 30x. Well, again, none of them are 30x, but there is one that has bounds 4 to 6, and it's close to 30x. Again, I just need to multiply that original 4 to 6 of 15x by what to make it say 30x? I'm going to multiply that by 2 as well. So I get a nice answer of 4. Letter C. All right, I've got a plus or minus in there, so I've got to do my split. All right, so I'm going to say it's 1 to 5 of 6x dx minus, in this case, the integral from 1 to 5 of 6 dx. All right, watch that split. Don't fall for that. That's going to be, on our free response, on our multiple choice. When you're adding or subtracting in an integral, split. All right, so I know 1 to 5 of 6x dx is 6, okay, minus, now this one I have to just do geometrically, and that's what we've spent the past couple of days doing. Graph y equals 6, and you need the area from 1 to 5. All right, what is your base if you went from 1 to 5? Hopefully you know that's a base of 4, 5 minus 1, the difference between there, and a height of 6. So I'm going to say minus 24 or negative 18. Okay, watch that split. All right, question D. You've got that one on your own. Pause it, see what you get, and then let's see if we get the same thing. Pause it. All right, let's just see if we split correctly. I noticed the 1 to 5 only goes with 6x, so to get a 12x, I just need to multiply that by 2. So I said I have 2 of those for a total of 12x, minus, split them up, 1 to 5 of 1. Let's see, that 1 to 5 of 6x is 6. So this is 2 times 6 minus, this one I have to do geometrically, I'm graphing y equals 1 from 1 to 5. So that tells me I have a base of 4 and a height of 1 if it's y equals 1. So minus 4, 12 minus 4 equals 8. Well, that's just about going to sum it up for tonight. Lots of integral properties that we need to be pretty familiar with. And really, just take your time on that split. I think that's where we're going to make the most mistakes, and just slow down, and every time you see that plus or minus, make sure we split. Have a great night. We'll see you tomorrow.